I'm all about good optical health, and that's why I want to talk to you about division. Let's talk about dividing rational functions, or rational expressions in this case. I have this rational function, x squared minus 2x minus 35 over x plus 6, and I want to divide that by this whole rational expression over here. And maybe it would be helpful to think about when we divide fractions, if I divide 1/2 by 3/4, the process that we've learned for dividing these fractions is we end up multiplying 1/2 times the reciprocal of whatever I'm dividing by. So we're going to use that same mentality here. And I would then just multiply these fractions just like I have before. So as far as a first step, what I'm going to think about doing is let's factor everything. Hey, why not? Just like we did in all the other examples. Let's factor everything. So this first polynomial, or this first polynomial numerator is going to factor into x minus 7 times x plus 5. That's all over x plus 6. And that's going to be divided by x plus 1 times x plus 5 all over x plus 6. And at this point it's factored, and we want to look for restrictions. And I'm going to say that here we're going to have a first look at restrictions. And I'm going to say why in a second, but you know what I'm going to do? I'm going to kind of keep like a restrictions bank over here. Because as we are dividing, we might find that x's appear in the denominator later, if that makes sense. You'll see what I mean. So far, if I just look at these two the rational expressions, I just see an x plus 6 in this denominator and an x plus 6 in this denominator. So I know that x cannot equal negative 6. But now at this point, I have split everything up. So I want to now change this into a multiplication problem where I'm going to multiply by the reciprocal. So what I'll do then is I'll keep this fraction the same. I'll keep that rational expression the same thing. X minus 7 times x plus 5 all over x plus 6. And now I want to multiply by the reciprocal, x plus 6 over x plus 1 times x plus 5. And here's where we need to kind of go back to the restriction bank. This is like now where I'm making my second look for more restrictions. Because if you can see here, now I have different stuff in another denominator. This still is a denominator, and so I need to look at what restrictions are in this denominator. If here I have restrictions of x cannot equal negative 1 and x cannot equal negative 5. Right? That's going to cause a 0 in this denominator, in this new fraction. So those are still going to all be restrictions. Now we're going to do just like we did before. We're going to reduce, and then we'll state restrictions. All right, so let's see. I can reduce an x plus 5 here, and an x plus 5 here, an x plus 6 here, and an x plus 6 here, and it looks like all that I'm left with is x minus 7 rather, over x plus 1. And I'll say that x cannot equal the set of numbers. Let's look at all my restrictions. I've got negative 6, negative 5, and negative 1. So division involves a little bit more of a process than multiplication, but really it's similar concepts to just dividing regular old fractions. So when in doubt, think about what your original process is just with regular numbers, and you should be in good shape. Why don't you try this example right here using the same process, pause the video, and see how this one went. All right, here's my solution, x minus 5 over x plus 10, and I have these three restrictions, negative 10, negative 4, and 0.